Today we're going to start discussion regarding the centripetal force, and let's see how it works and what are the things that surround it, right? Okay, so centripetal force is a force that is required to ensure that an object maintains a circular motion, right? So there will be a component of velocity, which is generally at an angle of 90 degrees. So if we draw this circular arc again, and if this is our object, that is trying to rotate in this direction, then there will be a centripetal force towards the center of the circle, right? And there will be a tangential component of velocity, and there is going to be an angle of 90 degrees between them. Now, no matter where the object is, this angle will not change. So for example, if an object would exist at this location, the component of tangential velocity or velocity will still be in this direction according to the direction of the circular motion, right? And there will be a component towards the center of the circle representing the centripetal force. And according to second law of motion, which is that a resultant force produces an acceleration, and consequently F equals to ma, in whatever direction there is a force, there will be an acceleration as well. So the component of acceleration is also towards the center of the circle, which is represented as AC, and FC is the centripetal force. In some questions, he generally asks that what will happen if the force or the centripetal force ceases to exist, if it is no longer there. So if the centripetal force ceases to exist, for example, or somehow vanishes, then the object will continue its direction of motion in terms or in the direction of the velocity. This generally happens in the case of a car or a motorbike or a vehicle that is trying to take a turn around the corner when it generally skids due to lower friction. So when the friction reduces between the tires and the road, it loses its contact, it loses its grip, and eventually the centripetal force vanishes and the object eventually starts moving towards the direction of tangential velocity, right? Okay. So here are some common examples of centripetal force, but in every case, the main idea is that the logic or the total understanding begins from the idea of centripetal force. The centripetal force is doing all of this. So to cause a circular motion, there needs to be a centripetal force. But in every case, we need to identify what is the cause for the centripetal force, or you can say which factor provides the centripetal force, right? So in this case, in the first one, in which we see a spinning ball on a string, we see that the centripetal force, most definitely Fc, is being provided or is being generated in the system by the force of tension that is between the string, or that is within the string between the hand and the object, right? So we cannot just say that the centripetal force is causing the circular motion. We need to identify which force exactly provides this facility to this object that is trying to rotate, right? And in the second example, car taking a turn or a bike taking a turn, or even as a person, a human being who is running in a straight line and wants to take a turn left or right, there needs to be a centripetal force towards the center of that imaginary circle, whatever the circle is trying to be covered in that distance, right? So in this case, there needs to be, or the centripetal force is being provided by the friction between the tires and the road, right? In the third example, we have planets orbiting around the sun, and most definitely in this case, the centripetal force is being provided by the gravitational attraction. If there was no gravity, if there was no gravitational attraction between the objects, the Earth would continue in the direction of the velocity that is represented by this arrow. And remember again that the angle between the force and velocity is 90 degrees. They're always at 90 degrees, right? And the last case, we have an electron orbiting the nucleus. Now, electron has a negative charge. The nucleus has a positive charge, so they will be attracted towards each other due to the electrostatic force of attraction. So in this case, the centripetal force is being provided by the electrostatic force of attraction between the positive and the negative charge. Now, nucleus is positively charged, electron is negatively charged. So there are some of the common examples where the centripetal force is there, but we need to identify its provider, its creator, its maker, right? Where it's actually coming from. Now let's look at a few examples of centripetal force. In the first question, it says that the motorcyclist is leaning towards this side. In order to move around a corner, which force causes him to move around the corner? Now, D is the weight of the object and B is the normal reaction, right? These are not the forces responsible for doing that. In fact, if the motorcycle is taking a turn in this direction, then there needs to be a centripetal force in this direction. Now, most common answer, the most obvious answer is option A, right? In question number 2, it says that the object wants to take a turn. In which direction the resultant force is there? Now, the resultant force is, however, a reference to the centripetal force. So in which direction that should be? A is not a component, C is not a component. Yes, B could have been a component. If we extra plot this, then this is a 90-degree angle. B would have been the tangential velocity or simple velocity if the car is actually taking a turn like this. So since it's a velocity, not a force, we are looking for a force. Option D will be the best answer in this case. Question number 3, it says which statement is true? The direction of motion. This is the direction of the motion of the rotation. Right? So this should be the direction of centripetal force. Notice that it does not matter whether the object is rotating, let's say in this direction. Even then the centripetal force will be towards the center of the circle, no matter wherever the object is. So it says a force is a constant size. Yes, the size is constant. Is on P, direction of motion. No. A force constant sign acts on P towards O. Yes, this is the most probable option. A force P, where is no. The force, that centripetal force, it has a constant magnitude. Its value is constant. It has a constant magnitude, but its direction changes. Direction changes, right? And how does that happen? So, for example, if you go back, in this case, if the object was in this location, the centripetal force would have been in this direction. If the object was in this location, the centripetal force would have been in this direction. So at every location, the centripetal force is always acting towards the center of that imaginary circle. So most definitely these vectors are different from each other, right? This is a different vector, this is a different vector, this is a different vector, but the value, it will still be the same. Okay, so again, a common question, an aeroplane is leaning towards the left side, right? Your C is the weight of the aeroplane, B could be the lift, and A again is the normal reaction or component of B. So D is actually our centripetal force that enables the aeroplane to lean and make a turn in this direction. Moving towards question number 5, we have a solar system. We have the Earth moving towards the center of the sun, moving around the sun in an orbit, right? So it says the direction of acceleration, which will be coming from the direction of force according to second law, and the direction of velocity, which is at a 90-degree angle with the force. So since it is rotating in this direction, right, the centripetal force should be in the direction of component R. So R is the direction of centripetal force, and consequently, similarly, same is the direction of acceleration. So R should be that. Now, since we don't have any other option, we can straight away choose D for the answer, but let's look at the other component, and Q will be the component for velocity. So Q is the component for velocity. Again, the answer would be option D. A satellite is orbiting the Earth direction of force on the causes the circular motion. So if this is the Earth, for example, if this is the Earth and if this is the satellite that is rotating around the Earth, then it will be towards the center of the circle that the satellite actually covers around the Earth. So it's away from the center of the Earth? No. It is towards the center of the Earth. In the direction of motion? No. But option B suggests that it is actually in this direction, the centripetal force, which is a wrong concept. In the opposite direction to the motion of the circle? No, this is not the case. Towards the center of the Earth? Yes, this is the correct answer, as this is your centripetal force. Question number 7, again, a visual based question, very common question. Straight away, if it's asking about the resultant force causing this moon to move around the Earth, then there is only one option, and this is the direction of rotation. This is the centripetal force. This is the direction of centripetal acceleration. C is velocity. Now, since this is not asked from us, so I will not mark this as an answer. Question number D, or you can say option D, used to be centrifugal force, but that is a pseudo force. It doesn't exist in real life. It's not a part of your course, but still mentioned here for some students to get confused about it. For those who have actually read about centrifugal force, this is not important in our syllabus. Let's leave it at that, and let's keep it simple. And whatever force is ensuring or whatever force is causing the object to move towards the center of a circle or in a circular motion will always be pointing towards the center of the circle. Straight away, straight option, simple. No, nothing else has to be discussed or thought about it. And this is that is all for today. I'll see you in the next lesson.